All right, let's talk about supply, demand, and market equilibrium. Now, you've probably heard about the concepts of supply and demand before. They are very fundamental concepts in economics. And so, for example, if you live in Western Washington right now, there is a very high demand for housing, but a very low supply of houses that are being sold. And that is likely due to the coronavirus. So, market equilibrium occurs when the quantity of a commodity demanded is equal to the quantity supplied. That is definitely not happening in the housing market right now. The law of demand states that the quantity demanded will increase as price decreases, and the quantity demanded will decrease as price increases. That should make sense, right? Like if you have an iPhone and you start selling them, Apple starts selling iPhones at like $2,000 per phone, then the demand for them will go down because that's very expensive for a phone, right? The law of supply states that the quantity supplied for sale will increase as the price of a product increases. All right, and this figure or graph here just kind of shows the concept of the equilibrium price and the equilibrium quantity. It's when the supply and the demand are the same there. Those linear functions are crossing. So we can actually solve for that. We see here that we are given the supply equation and the demand equation, very similar to what we did in break-even analysis. Notice that those are both equal to P, and so we can set those equal to each other and solve for Q. So let's go ahead and do that. I'm going to take the supply equation, which is 1 over 10 Q plus 5, and set that equal to the demand equation, which is negative 1/10 Q plus 35. Now, there are many different ways that you can solve this equation. I like to multiply every term by 10 so that we can get rid of those pesky fractions. So I'm going to take 10 and multiply it to every single term. And if I do that, then I will get Q plus 50 is equal to negative Q plus 350. And now I just want to solve for Q. So I'm going to add Q to both sides. Those will cancel out. And I get 2Q is equal to, 2Q plus 50 is equal to 350. Then I can subtract 50 on both sides, and I get 2Q is equal to 300. And then if I divide both sides by 2, I get Q is equal to 150. Now, we just have a graph here and we don't know what the context of this problem is, but notice that this matches up with the equilibrium quantity here. And notice the equilibrium price is $20. So if we did this correctly, if I plug in Q into either of these equations, we should get that the price is $20. So I'm going to go ahead and plug that into the supply equation. So P equals 1/10 Q plus 5. Now I'm going to plug in the 150 that we got. And if I simplify that, 150 divided by 10 is 15 plus 5. And so that does give us the price that we want. So that was just us basically solving for the market equilibrium point. Okay, and this example is very similar. Example 4 says, find the market equilibrium point for the following supply and demand functions. Notice, though, this one is a little bit different because in the previous example, both of the equations were already solved for P, and this one is not solved for P. So I'm going to go ahead and solve for P in both of the equations so that we can set them equal to each other. So for this one, I'm going to divide both sides by 2. And If I do that, then we end up getting P equals negative 1/2 Q, and 56 divided by 2 is 28. And then this side, I will add Q to both sides. So I get 3P equals Q plus 34. And then I'll divide both sides by 3. And we get P equals 1/3 Q plus. Now, 34 is not divisible by 3 because I know that 3 times 11 is 33. So I'll just leave that as a fraction. Now I can set these two things equal to each other. So if I do that and I set them equal to each other, I will get negative 1/2 Q plus 28 is equal to 1/3 Q plus 34 over 3. And again, I want to get rid of those pesky fractions, and so what I'm going to do is I am going to multiply every term by 6. Now you might be asking me, Mr. Kwan, how did you get 6? And if you notice, all of the fraction denominators are either 2 or 3, and so 6 is the least common multiple of both of those numbers. And if you don't know what a least common multiple is, maybe you can do some research on YouTube or something and find out what a least common multiple is. For now, I'm going to go ahead and simplify this equation. So if I multiply every term by 6, then I will get negative 3Q plus, let's see, 28 times 6 is 168. And that's equal to 2Q plus 34 times 2 is 68. Okay, so now I'm going to add 3Q to both sides. And I'm also going to subtract 68 from both sides. And if I do that, then I get 100 is equal to 5Q. And then I can divide both sides by 5. And I get that Q is equal to 20. Okay, so I've solved for Q, and now I want to solve for P. So we have two equations that we could potentially plug Q equals 20 into, and I'm going to plug it into the demand equation because it looks a little bit easier to deal with. So let's do that. P equals negative 1/2, and our Q value is 20, so I'm going to replace it with 20. And then if I simplify that, negative 1/2 times 20 is negative 10, and then I can add 28 to that, and then we get P equals 18. Note that the example is asking us to find the market equilibrium point, and so we want an ordered pair. However, almost always in algebra, whenever we have variables, the way that we order the ordered pair, we do it alphabetically. So normally we would say that P is the input and Q is the output, just because that's the way that they come in the order of the alphabet. However, economists kind of break the mold in that sense. And if you go back to this image, notice that Q is our input variable and P is our output variable. So really our ordered points are looking like Q comma P. And again, this is kind of a weird thing in economics, but I want to follow that tradition of economics. Just in case any of you go on to study economics, I will follow that tradition. So when we're talking about the market equilibrium point, we want Q comma P. And again, sometimes silly mnemonic devices help you remember. I always think about the McDonald's sandwich called the Quarter Pounder, and it's QP, so 20 comma 18 is our market equilibrium point. So there's our final answer. Let's talk about example 5. This one's nice. It's again asking us to find the market equilibrium point, but here our supply and demand equations are already solved for P, and so I can just set them equal to each other, which is very nice because Mr. Kwan likes it when things are very nice. So I've gone ahead and I've set my two equations equal to each other. I'm going to add 4Q to both sides and also subtract 30 from both sides. And if I do that, then we get 190 is equal to 19Q. And then if I divide both sides by 19, oops, be careful. Those 9s and those Q's can look very similar. So then we get Q is equal to 10. And then I'm going to go ahead and plug that into my supply equation. And again, you can plug it into either equation that you prefer. I'm just going to go with the supply one for now. And I get P is equal to 15. Our Q value we found was 10. And then we can add 30 to that, which is equal to 150. And if I add 30 to that, we get 180. So again, quarter pounder, our market equilibrium point, $10,180. Yay, we're on the last example. Okay, example 6. So the total cost and total revenue for a certain product are given by the following equations. And we have a bunch of questions. The first one is find the marginal cost. Now, notice that the cost function here is linear. So the marginal cost will just be the slope. So it will be $38.80. The marginal revenue, again, the revenue function is a linear equation or linear function. So our marginal revenue will just be the slope of our revenue function, which is $61.30. Now, for the marginal profit, that will require us to figure out what the profit function is, which we do not have at this point. So remember, people read negative comments. So our profit function is equal to 61.30x minus the quantity 38.80x plus 4,500. Now if I distribute that negative sign, we get 61.3x minus 38.80x minus 4,500. Now 61, let's see, got to get out my calculator. So 61.3 minus 38.8 is 22.5 minus 4,500. So there is our profit function. So take a minute, maybe pause the video. Now that we have our profit function, what do you think the marginal profit is? If you said $22.50, then you are correct. Come on down and win your prize. All right, last part to our question. D says, find the number of units required to break even. Now, remember, there are two ways that you could do this. You can either set the cost function equal to the revenue function and solve it that way, or you can set the profit function equal to 0. I suggest doing it both ways and making sure that both ways gets you the same answer. I'm just going to set the profit function equal to 0 since we have it right here. So this is for part D. I'm going to say 0 equals 22.5x minus 4,500. I will add 4,500 to both sides. So we get 22.5x is equal to 4,500. And then if I divide both sides by 22.5, we end up getting that x is equal to 200. So we could say in order to break even, we need to sell 200 units. And that is our break-even value. All right, see you later.